So in the last video lecture, we discussed disjunctive syllogisms at length, and I briefly touched on a different kind of syllogism, which is called a hypothetical syllogism. I gave you a couple of examples, and here's just one in particular. If you're willing to help me out with this, then I'll return the favor. You're willing to help me out with this, so therefore I'll return the favor. This is a kind of reasoning that we encounter very, very regularly. And in fact, as we'll find out, there are many types of hypothetical syllogisms. What a hypothetical syllogism is, in a nutshell, is any form of argument that involves a hypothetical proposition. That is, a proposition of the form if P then Q, or if this then that. You notice here in this argument, the very first proposition is actually hypothetical in nature. It's not saying that something is definitively the case or something is true or it is false. It is just saying if this first scenario occurs, then this other thing will happen. And as I was saying a moment ago, there are all kinds of hypothetical syllogisms. There is on the one hand what we call pure hypothetical syllogisms, and then there are also what we call mixed hypothetical syllogisms. You can see here the difference between them. Notice that the conclusions are very, very different. And the mixed hypothetical down at the bottom, the conclusion is just saying that Q is true. Whereas up here, the conclusion is of the form of if then. It's saying if P then R. And notice that everything within this argument is hypothetical in nature. If then, if then. Whereas this one down here is only the very first proposition is if then. And the second one is not an if then, is just stating that one of these two component propositions is true. You can kind of read along with me that look at the pure hypothetical. It says if P then Q, if Q then R, therefore if P then R. But this is, like I said, it's purely hypothetical. It's purely saying this is possible. It's not saying that anything actually is the case. Whereas the argument down at the bottom, what we call mixed hypothetical syllogisms, these are of the following form. If P then Q, P is true, therefore Q must also be true. Now, next class we're going to look at syllogisms in more detail. I'm just giving you these so you can kind of get a taste for the different forms of hypothetical syllogisms. But in order to understand hypothetical syllogisms more, we're going to need to look at the backbone of a hypothetical syllogism, which is a hypothetical proposition. And there's a lot to say about hypothetical propositions. As I said a moment ago, a hypothetical proposition is just any proposition that is of the form if then. Notice here I have P and then Q. It doesn't necessarily have to be P and Q. It could be if not P, then not Q. It could be if P, then not Q. It could be a lot of different things that we say there. But if you have this if then kind of proposition, then you're dealing with a hypothetical proposition. Now, I'm going to introduce some terminology here, and it's really important terminology. It's not overly complicated. It's just sometimes students have a hard time remembering. But whatever we put in place the first part right here, we call the antecedent. If I had not P here, that would be, my antecedent. If I had Q right there, that would be my antecedent. Basically, whatever goes between the word if and the word then, we call the antecedent. Now, don't confuse this with, you might hear the word like, antimatter, right? That's a different prefix. If you hear the word like antimatter, anta, right here, A-N-T-E means before, right? And some of you might have heard the word like antebellum. That means before the Civil War. That's what the word anta means. So you can maybe remember anti, if like you say antimatter, anti, A-N-T-I means the opposite of, or contradicting something. So antimatter would be the opposite or the counterpart of matter. Anti-Christian would mean against Christianity. I don't know, come up with whatever you want, it doesn't matter. But A-N-T-E means before. So you can kind of remember that because it's coming before the other term that's mentioned. So the first term, whatever it is, if it's not P, if it's not Q, it doesn't matter. Whatever is between the if and the then, we call the antecedent. And then the second term we call the consequent. notice it's not the consequence, C-E, it's consequent with the T. So the antecedent and the consequent. I know that's, terminology, anytime you introduce it, can be kind of annoying because you got to keep the jargon straight. But it's going to be important as we move forward, because I'll just kind of casually throw out the terms antecedent and consequent. And like I said, the easiest way to remember, they come in alphabetical order. Hey, that might be the easiest way. Antecedent comes first and consequent comes second. The antecedent is whatever's coming between if and then. Now, there's a whole lot we can say about hypothetical propositions, and what I'm about to talk about, I hope isn't terribly confusing. But it's something I think will be important if we can keep matters straight. Whenever we talk about hypothetical propositions, it's not long before we start having to talk about what we call necessary and sufficient conditions. You may have heard people talk about necessary and sufficient conditions in other walks of life, but basically what a necessary condition is a condition that is a requirement for another event, idea, proposition. When you hear the term necessary condition, just think requirement. Whereas sufficient condition is not a requirement, but a guarantee of the occurrence of some event, idea, proposition, etc. So let me give you some examples of this language here. You might say something like oxygen is a sufficient condition for fire. That means oxygen is a requirement for fire. In other words, you can't have fire without oxygen. Now, notice that oxygen is not a guarantee of fire. If oxygen, for instance, were a sufficient condition for fire, what that would mean is that anytime oxygen was present, you'd also have fire. It's not saying that oxygen is a guarantee of fire. If that were the case, then we'd be engulfed in flames right now, every single one of us. Hopefully that's not the case. But if you say oxygen is a necessary condition for fire, that means it's a requirement for fire. Being at least 35 years old is a necessary condition for being president. That means that in order to be president, you must be at least 35. Now, being 35 is not a guarantee of being president. Otherwise, anyone that was at least 35 would be president, which would mean millions and millions of people in this country would be president. In fact, you wouldn't even have to be a citizen, so billions of people would be president. Because if it's a sufficient condition, that means it alone is a guarantee. On the other hand, here's another example. Being born American is a sufficient condition for being an American citizen, being born in America. Now notice here that this is not saying it's a requirement. It's not saying it's a necessary condition, because you could be a citizen in other ways, right? You might be a citizen by having been naturalized, and that would be a different way you could become a citizen. Now you might be wondering, why in the world are you talking about necessary conditions and sufficient conditions here? Well, because all of these express conditional or hypothetical statements. So, for instance, oxygen is a necessary condition for fire. You might say it a different way, which is, if there is fire, then there is oxygen. And what this is saying here is that anytime fire is present, you will have oxygen. In other words, oxygen is a requirement or necessary condition for fire. Here's another statement. If someone is president, they are at least 35 years old. That is telling you that being 35 is a necessary condition for being president. We could express the last sentence differently. If someone is born in America, then they are an American. This is telling us that being born in America is a sufficient condition. The antecedent is a sufficient condition for the consequent. And this is something that's important to understand about if-then propositions, is that the antecedent always specifies a sufficient condition for the consequent. And the consequent, this is in any true statement, I should mention, by the way. If you have a false hypothetical, that's not going to be the case. But the consequent always, by comparison, specifies a necessary condition of the antecedent. So whatever comes, like I said, in the antecedent right here, so for instance here the antecedent is there is fire, this is telling us that that is sufficient for there to be oxygen, and oxygen is necessary for there to be fire. Now this isn't telling us a sufficient condition. It doesn't by itself necessarily specify, let me back up a second, I'm sorry to say. Necessary condition doesn't specify all the requirements for the antecedent, because there are other requirements. Like in this statement I have right here, if there's fire, this is oxygen. This is just telling us one requirement for there to be fire. You also have to have fuel. That's another necessary condition. You have to have a spark. That's another necessary condition. So don't think that whatever comes in the consequent, it's never a guarantee. It's only what comes in the antecedent that is a guarantee of the consequent. Or you can look down here at this statement. Being 35, that's a requirement for being president, but that's not a guarantee that you'll be president. There are many other requirements. You have to be 35. You have to have been born in America. You have to receive the majority of the electoral votes. There are a lot of conditions that are going to be requirements. So when we look at necessary and sufficient conditions, we can express those in these hypothetical statements. And like I was saying, anytime you have a hypothetical if-then statement, whatever is specified in the antecedent, that's giving you a guarantee that if the antecedent occurs, then the consequent will occur. By contrast, it's also telling you that the consequent is a requirement, that you can't have the antecedent occur without the consequent occurring. So if you see the consequent, you know that the antecedent must have, or let me back up. If you don't see the consequent, you know that you can't have the antecedent without it. So this is important for understanding the relationship of if-then. It's not as simple as you might think. Let me give you one more example. And this one might have a limited appeal to some of you. I don't know how many of you grew up going to church as a young boy or young girl, but I had to go to church as a kid. And I remember like a perennial debate in church was what you had to do in order to be saved. For those who are unfamiliar, that's just what do you have to do in order to go to heaven, all right? And one debate that was very common was whether or not baptism, this was amongst Protestants a very popular debate, is baptism necessary for salvation? This is the way the question is asked. Now, what is that asking when you ask that? It's trying to determine what the necessary conditions for salvation are, or to enter into heaven, what those necessary conditions are. And so being baptized would be one of those. For those who don't know, baptism is there are different forms, but one very common form is that you get dunked in water, all right? There are you can be sprinkled, there are other things that can happen too, but let's just go with getting dunked, because that's the most fun, right? But the question is it a requirement? So is it a requirement? But I never heard anybody suggest that being baptized was sufficient for being saved. No one ever suggests that. Why? Because what would that mean? That would mean that baptism by itself, you don't have to change your life, you don't have to repent of sins, you don't have to ask for forgiveness. If baptism were sufficient, then just being dunked in water would wash a person of all their sins, so to speak. Which means anytime you took a bath and stuck your head under the water, if you ever did that once in your life, if you ever went swimming and jumped in, right, and submerged yourself fully in water, you would be saved, right? Because if baptism alone is sufficient, if baptism is sufficient, that means that basically the water itself is what is saving you. The act of being submerged in water, I should be more precise, is what is saving you. So it's important to understand that was just an example. Maybe that'll help clarify it for some people, the difference between necessary and sufficient conditions. But what's important here to understand is that what is being specified, the antecedent, establishes a sufficient condition. Now, note too, I should point this out, that what's a sufficient condition doesn't mean it's the only condition, right? So let me give you an example. So if something's sufficient, it doesn't mean it's the only condition that'll precipitate the consequent. For instance, let's say I said the following statement: if an atomic bomb explodes on my head, then I will die. Well, an atomic bomb exploding on my head, that is a sufficient condition. That will guarantee my death. But that's not the only way I can die. It's just a guarantee that my death will come about. You could say if, I don't know, you throw me in a wood chipper, right, then I will die. Well, being, thrown in a wood chipper, that's, all things being equal, a guarantee that you're going to die. But again, what's specified in the the antecedent establishes a guarantee that the consequent will occur. But it's not saying that it's the only guarantee. It's just saying this is a guarantee that the consequent will occur. So, that may be of some value to you guys. Actually, believe it or not, these distinctions of sufficient conditions and necessary conditions become really important in a lot of different important philosophical, even economic conversations. So it's very strongly related to this hypothetical if-then reasoning. So it might be actually somewhat important later on in this lecture, but I just put that in your back pocket. Now, when we were going over categorical propositions, I imagine that some of you probably thought of categorical propositions in your head in just the following way. You'd hear a categorical proposition like all dolphins are mammals, and then you might even in your head think, well, that's kind of like saying if something's a dolphin, then it's a mammal. And oftentimes I do find, actually for myself and students, a lot of times it's easier to kind of think in terms like down here at the bottom in this like hypothetical if-then way than thinking in categorical propositions. It's sometimes easier to think in hypothetical propositions than to think in categorical ones. And I know, in my face-to-face class, a lot of times I get a lot more feedback from students. I get a lot more back and forth. And I'll just have students, when we're going over categorical propositions and I'll present something like all dolphins are mammals, they'll just say, well, that's like saying if something's a dolphin, then it's a mammal. And the truth is it is a lot like saying it. And I want to pause here for a second and talk about some similarities and differences between these, because it'll help flesh out our understanding of these hypothetical statements a bit more. So I want to begin by just stating some differences between, and I say down here, I say categorical propositions. Actually, that's fine. But I want to state some differences between, and we'll focus on particularly universal affirmative categorical propositions and hypothetical ones. But one difference between them is just categorical propositions in general. They show relationships between classes. I've said this many, many times. All dolphins are mammals. We're talking about the terms in that statement. One term is dolphin, the other term is mammal, and we're showing the relationship between those two classes. We're showing, again, like the connection, and I always think in circles because of the Venn diagrams, but how do these two classes overlap with one another? Hypothetical propositions, they actually show something different. They show cause and effect relationships. If this occurs, then this other thing will occur. Usually, there's different things that they show cause and effect relationships between, you might say between facts, between events, between possibilities. I have cause and effect, but they also show logical relationships between various propositions. If this proposition is true, then this other one will be true. In other words, if the first proposition is true, that leads to this other one. It logically requires you to also accept this other proposition. Also, we use hypothetical reasoning and means ends reasoning. It's like, if you want to be physically fit, then you must exercise. Notice I'm setting up here a means in order to achieve my end. My goal would be to be physically fit. My means would be to exercise. I have that if you want to be healthy, physically fit, then you must exercise. We use that hypothetical reasoning to show the relationship between your goal and the way you're going to achieve your goal. So there are some subtle differences between categorical propositions and hypothetical ones, but there are also some really important and key similarities. And one key similarity is that neither universal affirmative, and we're only focused on universal affirmative, propositions of the form all S or P, they don't have a logically equivalent converse. You can't say all S or P is not logically equivalent to all P or S. But the same is true for hypothetical propositions. They also don't have a logically equivalent converse. And let me just give you some examples, and this will help demonstrate what I'm saying here. But if I say all cats are mammals, well, that's a true statement. But that is not the same as saying all mammals are cats. Remember, a converse we find by just simply swapping out the subject, reversing the order of the subject and the predicate terms. Well, these two statements are just not logically equivalent. But look at the statements down here. If something is a cat, then it is a mammal. Well, that's definitely true, but we could find the converse of this. We could take this proposition here, this component proposition. We could take this component proposition here. So the first one is something is a cat, the second one is a mammal. Suppose we swap these two, that would enable us to find a converse. But notice that while the first statement is true, the second one is completely not true. If something is a mammal, it's a cat. That's just completely false. So just like universal affirmative categorical propositions lack a logically equivalent converse, so too do hypothetical propositions. Saying if P then Q is not the same as saying if Q then P. Those are just not the same at all. This I find actually a little more interesting because it's something that might not be quite as intuitive. But both universal affirmative categorical propositions, again, that's all S or P, it has a logically equivalent contrapositive. So too do hypothetical propositions. They also have a logically equivalent contrapositive. And this is actually, it's interesting because it's not as intuitive, but it's really, really helpful a lot of times. So I want to first, again, give you some examples. Now, again, when we find the contrapositive of any kind of categorical proposition, what we do is we swap the subject and the predicate terms, and then we find their complements, right? We could do it in order. You could say non-cat, non-mammals, and then switch them, but that's what you do. You swap the subject and predicate terms and also find their complements. So all cats are mammals. This is logically equivalent to all non-mammals or non-cats, right? Again, we could use the Venn diagrams in order to show this. We're not going to do this. You guys, or at least a lot of you, are sick of that. But I want you to look at this proposition right here. If something is a cat, then it is a mammal. Now, technically we don't find complements of these kinds of statements because complements are what we talk about when we talk about classes. But think about how we find a class complement. We're going to do something similar. Or we swap the order of what is, up here in the first proposition we said subject and predicate, but down here we're going to swap the antecedent with the consequent, and then we're not going to use non, because you don't say non to a proposition, you say not. You say a proposition is not true, you don't say it's non-true. So instead of using non, we're going to use not. And so we'll swap these, and then we'll throw the word not in both of them, just like we always found a contrapositive. So if something is a cat, then it is a mammal. The contrapositive of this is going to be if something is not, I got a typo here, if something is not a mammal, then it is not a cat. And that is logically equivalent to saying if something is a cat, then it is a mammal. Now, they don't quite mean the same, but they are logically equivalent, because think about what logical equivalence is. Logical equivalence is saying that these two propositions are true under all circumstances. And I want you to think about it this way. Earlier I was telling you, and this is why I talked about this, is that what occurs in the consequent sets up a requirement, sets up a necessary condition for what occurs in the antecedent. So if this doesn't occur, if the consequent doesn't occur, that means that this also, the antecedent, doesn't occur. And that's what exactly the second proposition right here is telling us. It's telling us that whatever let's say we're looking at some animal, I don't know what it is, it's some brand new animal, and we've determined that it's not a mammal, then we know it's not a cat. It just can't be a cat based on, this statement right here being true, the first statement being true. So this is actually something I want you, write it down right now or something, because it's going to become important later in this lecture. But hypothetical propositions, if P then Q, if P then Q is actually logically equivalent to if not Q, then not P. Hypothetical propositions have a logically equivalent contrapositive. That's something that's really important to remember. This is going to become critical somewhat later today and then as we move forward. All right, Now, I know you guys, I know how much you love standard form. You probably get sick of hearing that word standard form, but just like with categorical propositions, just like with categorical syllogisms, if-then statements, hypothetical propositions have a standard form. And the standard form is the word if is the very first word in the sentence. Then you have your antecedent, then you have the word then, and then you have your consequent. So I should have, if I was, being a little more careful here, I would have put if, the antecedent right here, the word then, and then the consequent. The big thing to keep in mind is the word if must come at the beginning of the sentence, all right? And then you have to specify whatever your antecedent is. And remember, the antecedent, the way it works is as a guarantee of the consequent. So, here, speak in English, do we always, when we make hypothetical or formulate hypothetical propositions, do we always begin them with the word if? No. Sometimes the word if is not even in hypothetical propositions that we utter. Sometimes the word if occurs in the middle. It can occur in various places. So in natural language, we don't always speak with if, then. Now we want to put it in standard form because we're going to try to determine validity of arguments down the road, and it's just going to make it a lot easier. But in order to do that, we're going to have to translate a lot of non-standard expressions into standard form. And this is actually a little tricky at times. So let me give you some examples, and then you'll see what I'm driving at here. So take a sentence like this: I'll go to the store if John does. Notice right here off the bat, this is not in standard form because if for no other reason, notice where the word if is. It's in the middle of the, well, somebody's technically 3/4, but whatever. It's in the middle of the sentence. It's not at the beginning. Here's the antecedent. John does go to the store. Notice that is not coming before the consequent. The antecedent must come before the consequent, right? It has to be if, antecedent, then the consequent. We don't have that here. You'll lose weight only if you eat properly. We actually, this one's going to be tricky, and we're going to talk about this at length. But here we don't even have the word if. We have the two words, only if. All right? And I'll come back to this later on, but that's saying something different than just the word if. John is a bachelor if and only if he is not married. Well, this isn't even the same, as what we had up at the top. Here we have a different expression, if and only if. Sometimes the word if doesn't even appear. You'll die unless you get enough oxygen. All right? So we have these non-standard ways of expressing hypothetical relationships or hypothetical propositions. And like I said, in order to have a logic that we develop and that we can work with and is easy to use, we have to be able to take these non-standard forms and put them into if, antecedent, then, consequent. So we're going to go through these, and some of these are going to be easier than others. Actually, I think probably, I always find that number 2 is the most challenging for students, but let's start with this one. I'll go to the store if John does. And first thing first, let's identify our component propositions and our connective. And here is pretty simple. I'll go to the store, and I say John does, but it would be John goes to the store or something like that. If we're going, just saying John does it's just a shorthand way of saying John goes to the store. Conversationally, we don't always spell out every single word and what we mean. Because we kind of, just leave it for the other person to, it's not even guess, they just kind of fill in the blanks themselves. But here we have our two propositions. Now, if we were to look at this and put this into logical form, right? If I said, what's the logical form of this proposition? Well, as it's written, we have to identify our proposition. So I'm going to say the first one is P and the second one's Q. And then I said, well, what if we, and we could have assigned any letter we want. I'm just beginning right here with P, and I'm going to say P refers to this statement. I'll go to the store. Q refers to this proposition. John goes to the store. And if I said, what is the logical form of this statement as it's written, it would be this, P of Q. Now, this is not in standard form because the word if is occurring in the middle of this expression. So we have to put this into standard form. And the way we do it is as follows. If Q, then P. Now notice I didn't say a second ago that standard form requires the P coming first. Standard form doesn't require that the P comes first. That's not what is required. What is required is that the antecedent comes first. And remember, the antecedent is what is providing a sufficient condition for the consequent. And this particular proposition, and basically what you're saying is, if John goes to the store, then I'll go to the store. It's just you've said it in reverse order, so to speak. You said, I'll go to the store if John does, but that means the same thing as saying, if John goes, then I'll go. So to put this into standard form, you actually have to reverse the order of these two sentences, or these two propositions. You have to reverse the order of P and Q. You know, if that's confusing to you, if you ever see a proposition and it's got, look right here, this logical form, I don't know if this is going to make sense, but if you see P, that means that P is latching on to this particular term right here, the Q. And think of P as the if as forming, I think it's a P, but the if is forming a tight bond with whatever it is that comes immediately after it. So go up to this sentence right here. Notice, or the proposition that comes immediately after if, that is what it's going to attach to. So since this proposition is the one that comes immediately after if, they're going to be bonded together, and you can't break it, right? If and John does, those stick together. So I don't know if that makes sense or not, but hopefully it does to some extent. All right, that one I don't think is tricky. This next one is probably the hardest one for students to see. But you'll lose weight only if you eat properly. Well, let's kind of do the same thing we did in the last one and identify our component propositions. And we're going to just like before, we'll just say P is you'll lose weight, Q is you eat properly, and our connective here is only if. And if I were to ask you, so what's the logical form of this proposition? Well, as it's written, here it is, P only if Q. Now this is the part that is tricky for students, because only if does not mean the same thing as if. These mean very, very different things. Only if, so if I say if is a conditional. Only if, however, is stating a requirement. Only if is stating a requirement of what's occurring right here. So if I say P only if Q, that means Q is required. P will only occur if Q occurs. Now think about what I was saying earlier in the lecture. Whatever is required or necessary, that comes in the consequent, right? That comes in the consequent. The consequent comes after the word then. And so here's how we would say this. If P, then Q. That is standard form of P only if Q. Whenever you see P only if Q, you basically just leave P and Q exactly where they are, and you say if P, then Q. Now that might be a little tricky to some of you, and some of you might be scratching your head and like, I don't get that. So I'm going to try to explain this in another way, and what I'm about to say I think will clarify a little bit. So forget about that, and let's think about it this way. Look at this sentence right here. You'll lose weight only if you eat properly. What are you saying here? You'll lose weight only if you eat properly. Well, basically what you're saying is, if you don't eat properly, then you won't lose weight, right? You'll lose weight only if you eat properly. That's the same as saying, if you don't eat properly, you won't lose weight. So think about that for a second. Now, let's look at this, and let's symbolize this proposition here. And notice here, we are using Q to represent you eat properly. Well, right here I'm saying you don't eat properly, so that's not Q. And right here I'm using P to represent you'll lose weight. Well, down here I'm saying you won't lose weight, so that's not P. So you could say if not Q, then not P. That's one way to symbolize this. And technically this would actually be in standard form, because you have your if and then you have then. So I mean, I wouldn't have a problem if you put it this way. But here's why what I was saying earlier, you could just write if P then Q, because remember what I said earlier, which is that, and this I told you was going to be important, is that hypotheticals have a logically equivalent contrapositive. So saying if you don't eat properly, then you won't lose weight. Well, what's the contrapositive of that? The contrapositive is if you lose weight, then you eat properly. Because notice here, what have we done? What have we done? We've taken this proposition, we've swapped it with this one, and then we've negated I've negated what's in brackets here, which is you won't lose weight. Well, that would be you lose weight. And right here, what is the opposite of you don't eat properly is you eat properly. So I found the contrapositive of that. So in other words, if P, then Q. So that's another way you could think about it, is because, actually that's easier for me, to be honest, is when I think about what's being said up here, you'll lose weight only if you eat properly. Well, it's like, that means if you don't eat properly, you won't lose weight, which is saying if not Q, then not P. Well, all hypotheticals have a logically equivalent contrapositive. So if not Q, then not P. Well, that's just logically equivalent to if P, then Q. So, like I said, actually, I wouldn't mind, it wouldn't bother me if, if I said, hey, if I were to give you this sentence at the top and I said, put that into standard form, and you wrote this one right here, if not Q, then not P, I'd be content with that. That's fine with me. All right. Here's another statement. John is a bachelor if and only if he is not married. Now, here again, we have to identify our component propositions, which is John is a bachelor and he is not married. And if I said, hey, put this in logical form, you might write P if and only if Q. Now, I want to point out here that this is a compound proposition. It's combining P if Q with P only if Q, saying P if Q and P only if Q. So the standard form of this is actually this: if P then Q and if Q then P. So I'll say this, we're going to, in a couple of classes, start to use P if and only if Q, and we'll just leave it like that. But I guess the reason I'm sharing this one with you is because A, the book does, but then B, because it's important to understand what an if and only if statement means. It is saying P if Q and if Q then P. Whenever you have an if and only if statement, actually another way of thinking of it, it means the following. It means that the first statement is true. If the first statement is true, then the second one is true. And if the first statement is false, then the second one is false, and vice versa. It means these two component propositions, they always, if one is true, the other is true. If one is false, the other is false. They always co-vary together. That's what an if and only if statement means. There's a term for what an if and only if statement is. We'll get to it later on. I'll just tell you right now. It's called a biconditional. And you can understand why, because another term for a hypothetical proposition is a conditional, right? Because if it's hypothetical, it's conditional. If it's biconditional, think about that for a second, because it's two ways. It goes from this statement to this one, and that one to that one. It's biconditional. If you don't get that, it doesn't matter. This is also a tricky one, but if you think about it for a second, I think it'll make sense. You'll die unless you get enough oxygen. Well, let's identify the logical form. P unless Q, that's how we could write it out. But here we don't have it in standard form, because standard form is if, if antecedent, the word then, and then our consequent. And we don't have that here. So how do we put this into standard form? What is P unless Q is saying? You'll die unless you get oxygen. If you were to use the word if, you were to translate this to an expression using the word if, well, basically what you'd be saying is, if you don't get oxygen, then you will die. In other words, if not Q, then P. And this is standard form, because like I said, look, standard form doesn't require that what we say in the antecedent is P and what we say right here is Q. So this is a little different than categorical syllogisms, because those it really mattered if S or the P came first. But here, what matters is not that, but the word if occurs, then the antecedent. The antecedent doesn't necessarily, in casual, normal English conversation, you don't always say the antecedent first. Sometimes you'll say the antecedent last. It's called the antecedent not because of its placement in the sentence, but because of its logical connection to the other event or proposition or concept that it's referring to, right? Or that it's related to, I should say, not that it's referring to. So what makes it the antecedent is that it functions as a guarantee for the other event, idea, proposition, whatever. That's what makes it the antecedent, not where it is situated in the sentence. So this is how we would put this particular proposition into standard form. Whenever you see the word unless appear, you should always translate it this way, is you basically find the word unless, then find the proposition that occurs after it, move that to the front of the sentence and say, if not this proposition is true, then this one is. So P unless Q is the same thing as saying if not Q, then P. So if you ever have any doubt about it, to me I always work with examples, because even I've been doing this for years, but even I sometimes will get a little tripped up with some of this. So I always, honestly, this is the example I always come back to. You'll die unless you get enough oxygen, because I'm like, okay, well that means if you don't get oxygen, then you'll die. It's a really simple one for me to remember. So anyway, here is just a brief layout of everything I was just saying, and you can see here all of these are lined up so that it's a quick reference chart for you. Your homework for this class, you're going to have to do these problems. They're on page 227 and 228. And basically, you're just going to have to go through and put these propositions into standard form. Identify the antecedent, identify the consequent, and put them into standard form. So if you have any questions, please feel free to email